This is Math 1, Test 7 for Unit 7. Let's dive right in. In number 1, we're supposed to determine whether the system of equations is consistent or inconsistent. Consistent means there is an answer. Inconsistent means that there is no answer. Independent means that there is one answer. And dependent means that there is an infinite number of answers. So I'm just looking here. I'm seeing that my y's don't line up, which is kind of a problem. Let's go ahead and move my x and my y. So that's x and y on my second equation. So let's move u over here. And that means this 15 is going to have to move over here. So let me do both those operations. You can do them at the same time. I can say, let's do minus 15, and at the same time, let's add a 9x and add a 9x. So my new equation becomes 9x, there's a positive 3y, which was the original 3y that's over here now. This 15 is gone, so now I'm going to rewrite the equal to sign. Over here, these are gone, leaving behind a minus 15. And let me go ahead and rewrite this first equation on top of this so I can see what's going on. Wait, before I do that though, I'm noticing 3x, 9x, they're off by multiple of 3, y, 3y, off by a multiple of 3, negative 5, negative 15, off by a multiple of 3. Let's go ahead and multiply this entire equation by 3 on both sides. If I do that, then I'm going to get 3 times 3x is 9x, 3 times a positive y is a positive 3y, and 3 times a negative 5 is a negative 15, and hey, same. If they're exactly the same equation, they're the same line. If you have the line and another line on top of it, there's an infinite number of answers. So which one of these means infinite number? So infinite number of answers means it's dependent. So there's dependent there and dependent there. So how do you decide which one it is? Consistent means that there is an answer and there's an infinite number of answers. I don't know how it's possible to even be inconsistent and dependent. Those seem like they don't work well together. But yeah, the correct answer here is A. Number 2. All right, so the system has how many solutions? Well, there's only 3 options to choose from down here. These are parallel lines. They at least appear to be parallel lines. I'm noticing that the distance between, there's not really a good distance there, is there? Because it's not a lattice point, but they appear to be parallel. Let's go ahead and trust that they're parallel. If it's parallel, then there are going to be no intersections with the lines, therefore no answers. So the correct answer here is no solutions. You can circle that too if you want to do it. Number 3. Clark is going to go spend some money on shoes and a jacket. So a total means you're going to add some amounts. And total is 46. So you're going to add the 2 amounts and get 46. Oh, look, adding 2 amounts. I bet it's going to be 46 right here. Let's just keep reading. The shoes cost $8 more than the jacket. That's interesting because that usually means $8 more than usually indicates you do something and then you add 8 to it. But I'm noticing nowhere in here does it give us room to add something. I'm subtracting something, so there's something weird going on. Write a system of equations to find the cost of the shoes, x. Okay, so x and jacket, if I add those together, I'm going to get the total amount. X plus y adds up to 46. So this first blank here has to be a 46. That's pretty, that was kind of what I was going to guess too. And then find the cost of the shoes. So the cost of the shoes. Okay, so the cost of the shoes is x. So I'm just going to write a note to myself, solve for x right here for the shoes. Okay, so there's the first equation is just total of 46. That literally says the total is 46. And then I need another equation that says the shoes cost. So that's the same thing as saying the shoes is $8 more. So the cost is kind of an is word, so that's an equal to word. So you're going to say the shoes, aka the x, because that's the thing I'm trying to solve for, right? It says shoes are x. So x is equal to, I'm just copying it down, right? X is equal to 8 more than the jacket. Well, that means you're going to do something and then add 8 to it. So something plus 8. And that something is the jacket, and it says that the cost of the jacket is y, so therefore I'm going to say y plus 8. And you'll notice this equation is not able to be written because it says y is over here. So they rearrange this equation, which is not cool. They try to get y by itself. Look at y by itself on the other side of the equal to sign. So this y needs to be by itself. So let's get rid of this 8 by subtracting 8 on both sides, and now we have y is equal to x minus 8, and check it out. So if y is equal to x minus 8, y is equal to x minus 8. Okay, so we have our system of equations, and now we actually need to solve for x. So let me go ahead and think about how I'm going to do this. Okay, so I'm noticing that this y right here is isolated. Whenever you have a variable that's isolated, it kind of leans more towards substitution, where if this y is x minus 8, this y is also x minus 8. So I'm going to substitute x minus 8 in for that y right here. So I'm going to go ahead and rewrite this equation down here. So here's my x plus y is equal to 46. And in the place of this y, as I told you before, this y is the same as this y, therefore this x minus 8 gets plugged into here. Do that in a different color, this will be x minus 8. And then I just need to solve for x. Notice I have one equation, only one type of variable. There's no x's and y's, it's just x's. I'm noticing I didn't give very much room for myself, so what if I grab you guys and can I shrink ray you down and move you off to the side? There you go. Let's grab all of these and solve over here. Okay, so solving this, plus parentheses. Whenever you have a plus in front of the parentheses, you can kind of just drop the parentheses. So there's my new equation, x plus x minus 8. Well, x plus x is 2x, so I'm going to say that that is 2x, and then I still have to rewrite my minus 8. So minus 8 is equal to 46, and then from there I'm going to add 8 to both sides, add 8 to both sides. 2x is now going to be equal to 54. And then from here, I'm going to divide both sides by 2, divide by 2, and x is equal to 27. Now, was I trying to solve for x or trying to solve for y? I know I'm only doing one of them. It says solve for x, solve for shoes. Shoes is 27. I come down here and say this is 27. Excellent. Moving on to number 4, which shows a system of equations that can be entered into a graphing calculator to solve. And there's like a hard equation here, a hard equation here. The general idea is you say y is equal to this first equation for one of them, and y is equal to this second equation for one of them, and you're done. I noticed that a lot of students chose C. That is incorrect because that's not a y equal to. You have to have a y equal to somewhere, so it's not C. All of these have a y equal to for A, B, and D. However, this one is just one equation, and this is like half of the first equation. It ignores the negative 2.3, and this is half of the second equation, ignores the 18, which doesn't make sense. What's going on with D? D is just 13.7. I think they added, or they subtracted 16.9 and 3.2, and they subtracted 2.3 and 18. Okay, you don't combine them that way. It's a good guess, but no. You just set the correct answer, if you haven't figured it out, is B, because you just want to set y is equal to that side, y is equal to that side. All right. So now it says do that, right? On a different system, you have something hard equal to something hard. There was one student that tried to do this by hand and you got the right answer. I gave you full points, but what you're supposed to do, which is much easier, is just do two equations, right? The first equation is y is equal to 1.1x plus 1.5, and your second equation is y is equal to negative 4.5x plus 5.7. So let me go ahead and pull up my calculator. I'm going to use the graphing calculator, of course, and it looks like there's some stuff on it from Algebra 2. Okay, so I've got this ready to go. I'm going to type in y is equal to 1.1x plus 1.5, and I have y is equal to negative 4.5x plus 5.7, and I'm going to zoom in here on my graph. And I see if I just click on that point that they intersect, it intersects with an x coordinate of 0.75 and a y coordinate of 2.325. Well, notice that over here on my my answers, I'm looking, what is x? X is equal to what? So over here, I'm looking at the x coordinate, which is 0.75, and hey, that's one of the options. It is indeed 0.75. So you are the correct answer. 0.75 is the answer. That's how you use a graphing calculator. All right. Number 6 was really hard. I think it might be the hardest one on the test because these equations are all given in different forms. None of these, I guess one of them is kind of repeated because this one and this one are similar, but none of them are exactly repeated verbatim, which makes it really hard. So there's a trick, and the trick is notice that this line, and this line all have different y-intercepts. So yes, they might have the same slopes. I'm going to ignore the slopes because I don't care. I just need to find what's the y-intercept, because I know for a fact that this line is one of these three lines. All I have to do is find the y-intercept, and I can identify which line it is. So what that means is, for all of these, scratch out all the x's. The x's, the number and the x are the things that affect the slope. What I care about is the y-intercept, meaning get y by itself and find the number that it's equal to. So now this equation is much easier. I have 2y is equal to -8, which turns into, if I divide both sides by 2, let me show my work, divide by 2, you get y is equal to -4. You say, oh, well, y is equal to -4 is down here. That must be line 3, and you can label this one as line 3. What about this one over here? You can say, okay, well, this one is divide by, here, let me show my work. Divide by 3, and you get y is equal to -4. And you say, oh, y is equal to -4 is that line right there again. That's 3 is equal to 3. So if the same line is equal to the same line, you have an infinite number of solutions, and infinite number of solutions is option A. Okay, what about this? Let's do C, because I'm running out of room for B, but it's the same strategy. So you say, okay, well, I have nothing over here. If you scribble it out, you assume it's a 0. So I'm going to say this is y plus 4 is equal to 0, and then I'm going to subtract 4, and I get y is equal to -4, and hey, that looks exactly like line 3, which has a y-intercept down here at -4. So this is line 3 again. And then this one is done for us, and y is equal to 2. Y is equal to 2 is this y-intercept right here, therefore it's talking about line 1. So this is line 1. So what do you notice about line 3 and line 1? Well, line 3 is here, line 1 is right here. Those are parallel, they will have no solutions. So the correct answer here is no solutions is the C. And just to, I'll try to squeeze it in here. If I divide both sides by 3, divide by 3, this is y is equal to 4. And y is equal to 4 is 1, 2, 3, 4. This y-intercept right here, which is referring to line 2. So let me go ahead and label this one right here is line 2. And this one over here, I think that's a 5. 5y is equal to 10. Divide both sides by 5, divide by 5, and y is equal to 2. Y is equal to 2 is this y-intercept right here, which is this line right here, which is line 1. So I can say this is line 1. So notice I have line 2 and line 1. Line 2 and line 1 intersect at one spot. It's technically that spot right there, if I could draw my lines correctly. And that means I have one solution, and that solution is -1 and 3, -1 and 3. That indeed is B. So the correct answer here is B, then C, then A. All right, we're on to number 7. This one's a bit tricky because you have to, you basically have to solve, because you're solving and getting no solutions, solving, getting one solution and finding what that solution is, or you're solving and getting infinitely many solutions. It goes on to say, hey, if the system has one solution, name the solution. I think there were 1 or 2 students that said, oh, it's one solution, and you were right, but you forgot to name what that solution was. So here's how I would solve this. I notice that the x's, y's, and the constants are all lined up, which means I want to use elimination. You can choose to eliminate the x's or the y's. I'm going to eliminate the x's here because the x's are a smaller number, that's a bigger number. So I'm going to multiply this entire equation by 3. Again, another reason is that these x's are opposites already. One of them is a negative, one of them is a positive. That's not opposites already, I guess, but it's really easy to be opposites without multiplying by a negative and getting confused by signs. So I'm going to multiply the top equation by 3 on both sides, and I'm going to get the new equation, which I'm going to write in the box where my answer is supposed to go, but that's okay. This is going to be -3x. Okay, that was that one. And then 3 times y is a positive 3y. There's my equal to sign. 3 times a -5 is a -15. And then I'm going to start adding all these straight down, right? Okay, so I should have eliminated my x's. 3x minus 3x indeed is 0, so those are gone. 5y plus 3y is a total of 8y. I guess I can do a little plus symbol to let you know what I'm doing. And 15 minus 15 is 0. Okay, you might think, oh, that means no solutions. No, it doesn't. Like, no solutions is a number equal to a different number. If I had 8 equals to 0, yes, you'd be correct. There's no solutions. I still have a variable, therefore there's going to be an answer. So from here, 8 is being multiplied by y. So to undo that, I'm going to divide by 8, and that gives me y is equal to, well, okay, what's 0 divided by 8? If I have 0 pieces of pizza and I'm dividing that among eight friends, each friend gets 0 pieces of pizza, so 0. So that's half of the answer, right? So it's going to be I'll write my answer right here. It's something comma 0 because the y coordinate goes second, the x coordinate goes first. So what is x? Well, I can plug y equals 0 into either this y or into this y. I'm going to plug it into this y because there's no coefficient out in front of it, so there's no multiplication. I think the first one is going to be easier to do. So let me rewrite that first equation. It says negative x plus y is equal to negative 5. And in the place where I have a y, I'm going to do substitution because I know y is equal to 0. So it's going to be plugging in a 0 here and plugging in 0. Did you know that negative x plus 0 is negative x? Because adding 0 doesn't do anything. So there's my new equation. Negative x is equal to negative 5. And to solve that, I need to get rid of a negative. A lot of people here will divide by negative 1. I'm going to be unique, and I'm going to multiply both sides by negative 1, multiply both sides by negative 1, because you can multiply or divide by negative. Both are fine. All right, so from here, I have a negative times a negative, which is a positive. Oh, in pen though, positive. And again, negative times a negative is a positive. 5 times 1 is 5, so x is equal to 5. So the answer is going to be 5 comma 0. So notice that we didn't really answer the first part of the question. The question asked, is it no solution, one solution, or infinitely many solutions? And I didn't say either one of those. So I'm going to come over here and finally answer the question. I'm going to say it's one solution. And I'm just going to box all of that for good measure. So there's one solution, and there it is. It's that solution, 5 comma 0. All right, number 8. Which expression could be substituted in for x in the second equation to find the value of y? So this one was really tricky. It even it might have tricked almost everyone. This one was tricky because you have to read the instructions. We have to substitute in for x to find the value of y. So that means you're solving for x. Whenever you're substituting in for a variable, that's the variable that you need to isolate. And you need to isolate either this x or this x because it tells you to substitute in for x. And you want to plug the x into the second equation. So that means you're solving for x in the first equation. So solve for x in the first equation. That just means move this 2y over to this other side. And then once I have that, I'm plugging x into the second equation, So all this question was really asking to do was solve for x in the first equation. That's it. Don't even solve the rest of this. So I have the equation x plus 2y is equal to 20. All I had to do was subtract 2y, and I get x is equal to 20 minus 2y. And that's the answer. And I don't see it. I see a negative 2y 20, negative 2y 20. Okay, they wrote it backwards, and that's okay. It's not really backwards. It's in a different order. So these two are the same as that. Therefore, the correct answer here is B. Just be careful because a lot of people did try to solve for this y right there, which I can understand. The instructions were a little bit tricky. If you did solve for y, you would get this answer, but it didn't say substitute in for y. It said substitute in for x, and then once you do that, you will get the value of y. Because when you plug this in for this x right here, notice that you'll have y's, because that has a y in it, y's and nothing else, and you'll find the value of y after that substitution. Number 9 was, again, hard to set up, but if you were able to set it up, then you solved it correctly. I think maybe 1 or 2 people this year were able to actually set up the equation. I think that was the hardest part, so let's make sure we spend some time on that. So I'm just going to call my first angle, do we have to use x and y? Let me read the question. Angles 1 and 2 are supplementary. And okay, so it doesn't tell us what to do. I'm going to go ahead and instead of calling this 1 and 2, that will get confusing because if I see a 1, I want to multiply by 1. I'm going to call this angle x and this angle y. Hopefully you're okay with that. So if it says that they sum to 180 degrees, that means they add up to 180. That means x and y add up to 180. My first equation is x plus y is equal to 180. A lot of people got here. And this is, the next step was probably the harder one. So it says that the measure of angle 2 is, so angle 2 I'm calling y. So I'm going to say that this is y, and then I don't know why I scribbled that out. But I'll just say angle 2 is y. And whenever you have the word is, that means an equal to sign. So I have y is equal to 3 degrees more than means you do something and you add 3 to it. So I'm going to do something and I'm going to give myself room plus 3. So this says something plus 3, which is 3 degrees more than what? Twice angle 1. twice angle 1 is twice of x, or 2x. So getting this second equation was really, really tricky. But again, the way that math problems typically work for word problems is they're almost literal. Like if you know that angle 2 is y, switch it for a y. There it is. If you see the word is, make it an equal to sign. 3 degrees more than or 3 degrees less than can be confusing because that happens after you write the 3 after and give a blank spot. But if you see that over and over again, you'll get used to it. Okay, so we have the setup, we just need to solve. So I'm seeing that one of my variables has been solved for, which means it's probably easiest to use substitution. If this y is 2x plus 3, then this y up here is also a 2x plus 3. So I'm going to rewrite this first equation, but in this spot of y, I'm going to rewrite 2x plus 3. So here I go. X plus y is equal to 180. Notice I've rewritten this first equation, but in the spot where this y is, I have a empty spot, an empty container where I'm going to plug in this 2x plus 3, and this is going to be 2x plus 3. So now I have one equation with only one type of variable, which means I'm doing something right. Again, I have this scenario from before where I have a plus sign with some parentheses. Whenever you have a plus sign and immediately parentheses, you can just drop the parentheses, and then you can get x plus 2x is 3x. So I'm going to say that this adds up to 3x. I have to rewrite the plus 3, and is still equal to 180 degrees. And then from here, we just do some basic math. We're going to subtract 3 on both sides, and that's going to give us 3x is equal to 177. And then I have to divide both sides by 3. Divide by 3, divide by 3, and x is equal to, in a different color though, x is equal to a number that I don't know very well. What is 177 over 3? Well, I'm going to find a number that's really close to something that's divisible by 3. So the first thing that I think of is 12. 12 is divisible by 3. So that means 120 is divisible by 3. And I'm realizing that's probably not the best number. 15 is also divisible by 3. So let me revise that and say it's 15 divided by 3. And I can go even further and say 18 is divisible by 3, and that's probably the fastest way to do that. I'm going to go there. I'm going to go with 18. 18 divided by 3. Notice that 180 and 177 are really, really close. I know 18 divided by 3 is 6. Therefore, 180 divided by 3 is 6d. So I'm going to write that's 6d right there. However, 180 is not 177, so I have to subtract 3. So I'm going to say I have to now subtract 3, and then to make like denominators, I'm also putting the 3's on the bottom. So 180 minus 3 is 177, and then 3's are the 3's. That's good. Did you know that 3 over 3 is the same thing as 1? Bet you did. So really what I have now is I have this equation that says 60 minus 1, which is 59. So I'm going to come down here and say that's 59. So I have one of the two angles solved for, it's 59. And it does tell me in the instructions that write a system of equations, and I told us to use substitution. Good thing I used substitution. If I used elimination, I would have had to come back and redo this problem because I didn't read the instructions correctly. And it tells me to find angle 1 and angle 2. I found angle 1, 59. I just need to find angle 2. So I can plug this x equals 59 either there or there. This one looks easier because there's no multiplication. There's just like some subtraction. I think I'm going to do the first one. Yeah, so I'm going to rewrite this x plus y is equal to 180 over here. This is going to be x plus y is equal to 180. And in the place of that x, I'm substituting in our previous value of x, which is 59, into this spot. I'm going to say that this is 59. Okay, now I just have to solve. Again, whenever you have there's an invisible plus sign right here, so you can just drop the parentheses. This now just says 59 plus y is equal to 180. I'm going to get rid of the 59 by subtracting 59 on both sides. Subtract 59, subtract 59. And from here I get y is equal to 100. And oh, this is another problem where I can show you how I think about math. This 59 is really hard to subtract. But do you know what's easier to subtract? 60, because I can say ignore the zeros, and 18 minus 6 is 12. So this is basically 12 with a 0. But the problem is I was subtracting 60 to get to here, which is subtracting too much. So if I subtracted too much to balance it out, I have to add a little bit more. So I'm going to add a little bit more, and I can get up to 121. And then you can just verify 121 plus 59 does add up to 180. Cool. So I have 121 and 59. And I should answer my word question with some words. I can say angle 1 is 59, and angle 2 is 121. It's just kind of a common practice that if you have a problem given to you in words, you answer it with words. You don't just say x equals and y equals and call it that. Just not as formal. All right, number 10. Fill in the blanks. What do we got here? Oh, it just wants an answer. It says, okay, use x right there and then y right there like we normally do. What's the answer? So I know that there's going to be one solution because one of the answers is not infinite solutions or no solutions. So how do I want to solve? And it tells us, unfortunately, solve the system of equations using substitution, which I do not want to do. I don't want to use substitution because my variables line up. Whatever. Okay, I will use the substitution that it wants me to. So I can either solve for that x, that y, that x, or that y. I choose this y. The reason for that is because it doesn't have any coefficient in front of it. It's going to be a little bit easier to solve for. So let's solve for this y by moving this 4x to this other side. The opposite of minus 4x is plus 4x on both sides, plus 4x on both sides. And my new equation is y is equal to 6 plus 4x. So from here, I can solve and I can say, if this y is 6 plus 4x, this y is also 6 plus 4x. So I'm doing my substitution like so, where I take all of this 6 plus 4x and plug it into this y. Let's go ahead and rewrite this equation over here. So this says 3x minus 2y is equal to 3. And in the place of y, I have a 6 plus 4x. So from here, I'm going to distribute. Be really careful on this one, because if you just distribute a 2 here and here, you will get an incorrect value for this last value because you did not take this negative 2 and distribute it here and here. So really, it's a negative 2 distributing to both of these, which gives us still a 3x that we rewrite. Negative 2 times a 6 is a negative 12. And then a negative 2, whoa, that's an eraser, Mr. Sindel. A negative 2 times a 4x is a negative 8x. And that's going to be equal to a 3. So I need to combine my like terms now. I have an x here, an x here. 3 minus 8 is a negative 5, so I have a negative 5x. Still minus 12 is equal to 3. Now I have all my x's in one spot all combined. I can move my constant to the other side, moving this 12 on the other side by adding 12 on both sides, adding 12 on both sides, giving me a negative 5x, which is equal to a 15. From here, I can divide both sides by negative 5, divide by negative 5, and I get x is equal to a negative 3, which you'll see down below is one of the answers that we are allowed to choose, negative 3. So now that I have a value of x, I can plug it back in to either this x or this x. Well, this one is my favorite because y is kind of already by itself. This one I would have to divide by negative 2 at the very end. So I'm going to plug into this equation. I think it's a little bit easier. So let me rewrite this negative 4x plus y over here, but in the spot where I have an x, I'm going to plug in a negative 3. So here I go. This says, do I have enough room over here? I have tons of room. So I'm going to say negative 4x plus y is equal to 6. And you know what I'm going to do? I'm going to plug the negative 3 in right here, and then I'm going to solve. So again, I have a negative times a negative, which is a positive. So this is going to be a positive 12 plus y is equal to 6. Let's go ahead and subtract 12, and y is equal to negative 6. Cool. And I hope that's one of the answers. It is indeed one of the answers, and I can write negative 6. Number 11. Order the steps below to show how you'd solve the system of equations using substitution. Okay, I'm going to underline that just in case one of them is misleading us and trying to do elimination or something. Let's read our choices. Since the first equation is solve for y, oh, yeah, that's kind of nice. Substitute 6x plus 1 into the second equation. I mean, that seems like a valid first step, but let's keep reading. Solve the resulting equation for x, which is exactly what I would do after I did my substitution. Write the solution. Okay, well, this is the solution. So this feels like the answer. And then check the solution. Okay, this has to go last. So I know for a fact C goes here because by now, if you wrote the solution and you checked your work, then you're done. D, substitute the value of x into either equation to find y. Okay, so this is one of those things where if you just solved for x, then you use that x and then plug it back in to find the next variable. So this feels like a step right before the answer. So I'm gonna go backwards and say that has to be a D, because that's the one where we just solve for x. So I think A and B were in the correct order. So it goes A, B, D, and C. Let's check. So you will solve the first equation is already solved for y, I agree. So you just substitute 6x into the second equation. So 6x is now plugged into this y right here. Now I have an equation that you solve for. So it says solve it now. Yep, we solved it. And then once we have a value, we will theoretically have an equation that says like x equals 3 or something like that. So we have x. To find y, we substitute that value of x into one of the equations to find y, which is what we did in step D. Okay, everything here makes sense. Then write the solution and check the work. Perfect. Number 12, solve the system of equations using elimination. Thank God it's elimination, it's my favorite. Okay, so elimination, notice my variables do line up and I'm ready to go. I even have opposites, look at this. 7 and -7, oh, I have opposites again, -12 and +12. Oh, I know it's about to happen. You probably can predict it as well, but let's try it. You can just add straight through, right? So if I add straight through, I'm gonna get 7x minus 7x is nothing. They're gone. -12y and 12y add up to nothing. They add up to 0. So on the left side of my equation, after I add them up, I get 0. That's going to be equal to, what happens when I add these two together? Well, -3 plus 2 is a -1. I have this scenario where I have a number equal to a number that is not the same number. If it's not the same number, it's no solution. The correct answer here is D. If I had the same number, like 0 is equal to 0, the same number and same number, it would have been infinitely many solutions, but that's not the scenario in number 12. In number 13, ooh, a word problem. Okay, let's go ahead and read through this thing. We are spending $2.50 for sandals, $4 for running shoes. We spent $2,500 total, and then we doubled the pair of sandals and made $3,000. Whew, that is a tricky problem. All right, well, I take back what I said from the problem before. This one seems like it's the hard. Okay, like if I didn't have multiple choice, I think this would be hardest, but the fact that I have multiple choice means you can kind of guess and check your way into this one. I just kind of want to solve it the old-fashioned way. Like, how would you solve this using a system of linear equations? Well, I want one equation for the first scenario. So an equation that says this stuff, and then make 2,500. And then I want another equation that says this stuff, but double, where does it say? Double sandals and make that much. So here's my first equation. So let's go ahead and say, I need some variables here. I'm gonna say sandals is the variable S. Hopefully my S's are curvaceous enough to not be confused for my very sharp angular 5s here. And I'm definitely gonna be doing running shoes are gonna be R, which can be confusing because S might be for shoes for the running shoes, but hopefully you can keep up with that. Okay, so what do we have so far? I have $2.50, $2.50 for sandals. By the way, you don't need that 0. It can just be 2.5. You're gonna be cool like me, right? 2.5 S, make sure your S is nice and curvaceous like mine. And then I add 4 of the R, and then if I do all of that in 1 month, I get $2,500. You can put as many zeros after the end if you want, but you're not gonna do that. All right, so from here, I have one equation, and how in the heck am I gonna create a second equation? During the month of April, they double the pairs of sandals. So I just need to double sandals and have the exact same scenario, except this number is gonna change to 3,000, right? So this one, this S is sandals. So I'm gonna take that thing, this term here, and multiply it by 2. So watch what I do. I'm gonna say 2.5 times 2. Technically this is times S, right? So times my curvaceous S plus 4R is equal to, instead of 2,500 now, it is this number up here of 3,000. 3,000. Okay, well I have my 2 equations set up, which was by far the hardest part of that process. I don't know how to make this easier on you guys aside from you just need experience practicing these things. Usually my strategy is I write down exactly what it tells me. 2.5 sandals, 2.5 sandals, $4 running shoes, $4 running shoes, total of 2,500, total of 2,500. Like, it's almost a literal equation. It tells you what to write down in your equation. Anyway, let's come here. Did you know that 2.5 times 2 is just 5? So let me cross this off and say that that's really just 5. Let me maybe make that another color. So this is just 5s. So one thing that I'm noticing is this 4r and 4r are just asking. They're begging to be eliminated. Like if I can somehow multiply this second equation or the first equation by a -1, I could add them and then I could cancel out those r terms and do elimination. So let me just put, I'm just feeling like the top one. I don't know. It doesn't really matter, right? I'm going to say the top one. Let's multiply this entire thing by -1. Multiply the entire thing by -1, and that's going to give me my new equation down here, which is going to be -2.5 with my curvaceous s plus, oh no, it's not plus, is it? Because -1 is being multiplied by a +4r, making this a -4r. So I have a -4r. That's going to be equal to my -2,500, -2,500. And check it out. These 4r's are ready to be eliminated. We can just add these up. What do we got here? So my favorite thing, you're gone, you're gone. Okay, what about here? 5s minus 2.5s is 2.5s. 2.5s. And that's going to be equal to, well, 3,000 minus 2,500 is the same thing as 30 minus 25 with some zeros. 30 minus 25 is 5 with some zeros. So 5 with some zeros. And then I have to divide both sides by, divide by 2.5, divide by 2.5, and I get my, my answer S is equal to, I'm mixing my fractions with my decimals. I don't like doing that. So one thing that you can do to not have fractions and decimals is to move the decimal place over. One way of doing that, the inefficient way of doing that, is to multiply the top and bottom by 10. If I do that, multiply by 10 moves the decimal place over. But there's a trick. I know how to get rid of a half. To get rid of a half, you multiply by 2. So while, yes, you could multiply the top and bottom by 10, I'm going to multiply the top and bottom by 2. Watch what this does. The top is now 1,000, and the bottom is now 5, because 2.5 times 2 is 5. And now I can say, oh, 1,000 divided by 5, that's a number that I might know. Okay, well, I happen to know this fact that, maybe here, without doing math facts, I can do another trick. I like teaching tricks, right? I don't like dividing by 5. So what I really do in my head is I say, I like dividing by 10. So let me multiply by 2 again. If I multiply by 2 again, this makes the problem a little bit easier because now the bottom is divided by 10. Whenever you divide by 10, all you do is move the decimal place 1 to the left. So if I do 2 times 1,000, that's 2,000. And 2,000 divided by 10, the decimal place is right here. You move it 1 to the left. So this now turns, you now have, and the quick way of showing this is cross off a 0, and it's 200. So this is going to be equal to 200. So over here, correct answer is 200. Yikes, 200. 200 sandals. And if you have 200 sandals, how many running shoes do you have? Well, you have to plug this 200 into, I meant to write 200 down here, S is equal to 200. I have to plug it into one of these spots, right? I can either plug S is equal to 200 there, or I can plug it into there. And both spots are kind of disgusting. The one thing that I do notice is that this number is nicer because there's no decimals. So let me do that one. I'm going to say that I have my equation, which is 5S plus 4R is equal to 3,000, and I ran out of room, so let me move you and scoot you right there. It's equal to 3,000, and in for the place of this old S is this new S of 200, so I'm gonna write in here a 200, and then from here I just need to solve. So last I checked, 5 times 200 is 1,000, so I'm gonna do 1,000. If you didn't know that off the top of your head, 5 times 2 is 10 with 2 zeros. 10 with 2 zeros is 1,000. Plus 4R is equal to 3,000. Let's go ahead and subtract 1,000. Subtract 1,000. 3,000 minus 1,000 is 2,000, and that's going to be equal to 4r. Dividing by 4 on both sides. I think you know the trick for this one, but just in case you don't, dividing by 4 is the same thing as doing a half and then another half. A half is the same thing as dividing by 4. So dividing 2,000 by 2, or taking half of 2,000 is 1,000. Half of 1,000 is 500, so 500 is my second number that I'm looking for. So 500 is that next number, 500. Whew, that was a tricky problem. There are decimals, there was a hard setup of the second equation, but there it is. You maybe learned something. Number 14. Ooh, we've got some mixture of geometry in here because we're in an integrated math class. So hypotenuse is the word meaning the side opposite of the 90-degree angle. So this side right here is known as the hypotenuse. And it tells you that the hypotenuse is 5y. So 5y is the hypotenuse. You don't need to know the terminology. It tells you that 5y is the hypotenuse. Legs are x plus 8, x plus 3. Legs is a fancy way of saying you have a triangle where the two things that are not the hypotenuse are called the legs. So these are called legs. Always, if you have a 90-degree triangle. The perimeter is 60 inches long. Perimeter of a triangle just means you add this length, add this length, add this length, add all three of them together, and you get 60. Well, to me, that sounds like an equation. Let me go. So I'm going to say x plus 8 is one side, plus x plus 3, which is the other side, plus 5y for the third side. If I add all three of those together, I get 60, because it tells me that they add up to 60. The perimeter is 60. Perimeter is that stuff. Is the equal to sign 60. It's a literal equation to me, okay? And it has this word and, the next equation, the length of the hypotenuse we know is 5y, so this thing right here, I'm gonna switch this out, length of the hypotenuse, aka 5y, so let me write down 5y, and this says minus, so that means minus, and then length of the shorter leg. Ooh, tricky. Which of these are the legs, right? Leg. Which of these two is shorter? The one that adds 8 or the one that adds 3? Well, adding 3 is the shorter one, right? So minus this x plus 3. So I'm going to do something wrong and write x plus 3. The reason that this is wrong is because this is saying 5y minus the x and then plus 3. I'm minusing this entire x plus 3, which means you have to have parentheses. This entire x plus 3 is being subtracted, so I do have the parentheses there. So let me read what I have so far. Length of the hypotenuse, 5y, minus, length of the shorter leg is, the word is always means equal to sign, and then 10. There we go. There are our two equations. Check it out. So the tricky part with this second equation is this negative sign gets distributed here and here, and our new equation really is 5y minus x minus 3 is equal to 10. So that's the second equation. What about that first equation? That first equation really needs to be rewritten because I have an x and an x that can be combined. I have an 8 and a 3 that needs to be combined. So this is really going to be 2x plus 11 plus 5y, and that's equal to 60. All right, well, now I have these two equations to deal with, and they look bad. There's too much going on here. There's numbers, there's a constant there, a constant there, a constant there, a constant there. Choose a lane, buddy. Let's make all of our constants go to the right side. So I'm gonna move some things over on both of these. So first, let's add a 3, so that new equation. Can I make my, let's do y first. So it's going to be y first, which is 5y minus x. It's going to be equal to 10 plus 3, which is 13. All right, so what about for our second equation? Our second equation, we are going to move this 11, this pesky 11, minus 11, and notice that it goes x, then y first. I want my y, then x. So I want this 5y first, so I'm going to have a 5y first, 5y, and then I have a 2x, so I'm going to say plus 2x, and that's going to be equal to 60 minus 11, which is 49. Okay, and now I have these two equations, which looks much nicer. Notice that I've lined up my variables, y's, lined up my x. Wait, what did I do here? 2x, 2y. Where did this 2y come from? I don't know. It's supposed to be 2x. Oh my goodness, Mr. Sindel, what are you doing? 2x. There we go. Okay, so this looks better. My y's are lined up, my x's are lined up, and my numbers are lined up. I'm ready to go for substitute or for elimination. So I have two options. I can either eliminate the y's or I can eliminate the x's. So the x's are kind of nice because one's a minus and one's a plus, but the y's are kind of nice because they already have the 5 and the 5. So I'm leaning more towards eliminating the y's. It doesn't really matter, but I'm gonna eliminate these y's right here. And since I already have a negative here, let's multiply the top one by a negative. It doesn't really matter. You can multiply the bottom one by a negative, it'll still work. So I'm going to say multiply that top equation by -1, multiply that side by -1 as well, and that creates a new equation underneath, which is a -5y plus an x, because again, you distribute the -1 into both of these terms, is equal to a -13. And now after, like, look how many times we've transformed equation, and finally we get these two equations that are lined up and ready to do elimination. We can go ahead and add these two together, and we can say, okay, 5y minus 5y, those two are gone and gone. Let me use a different color so you can see that they're gone and gone. And then 2x plus x is 3x. And then 49 minus 13, well, 9 minus 3 is 6, 4 minus 1 is 3, so 36. And then from here, divide by 3, and you get x is equal to 12. Whew, okay. Oh, what am I trying to solve for? I got x equals 12. What does that mean? How many inches long is the hypotenuse? Dang it. Okay, the hypotenuse is a length of 5y, which means we need to solve for y because we're trying to solve for the hypotenuse. This x equals 12 is not the answer, but it's going to help us, right? Because now I can plug in this x equals 12 either to this x 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 and this x. I have so many x's to choose from. Which one do I want to use? I kind of want to choose this one maybe, because there's just one and there's so many to choose from. It doesn't really matter, does it? I'm just going to choose this one. Okay, that one right there. I'm making a choice. I have a 5y minus, there's my x, is equal to 13. Okay, into this x goes a 12. There's my substitution. Okay, let's go ahead and add 12 to both sides. I'm going to say plus 12, and I get now 5y is equal to 15. And then I'm going to divide by 5, and y is equal to 3. All right, well, if y is equal to 3, then I can come up here and say this y is 3, therefore this y is 3, and the hypotenuse is 5 times 3, which is 15, which is not an answer on the multiple choice, and that means we've done something wrong. Oh, well, I don't know if you guys caught this, but 13 plus 12 is not 15. I'm glad it was such an easy mistake. It's right at the very end. Did you know that 12 plus 13 is 25, Mr. Sindel? And that's easy to fix. 25 divided by 5 is just 5. Whew. I was worried we did something wrong way back in time. That would have been kind of a pain in the neck to go back through all of that. Luckily, it's just y is equal to 5, and check it out. Plugging the 5 into over here, it's going to be 5 times 5. 5 times 5 is 25. The correct answer here is D, 25. Whew, and I guess I need to show my work. I can say that the hypotenuse is 5y, and 5y is 5 times 5, and 5 times 5 is 25, which is the final answer. Very nice. Number 15, select all of the ways the system of equations can be solved. Okay, so first, this question is a little bit tricky just because this says subtract the equations. In my class, I always add. So the fact that it's asking us to subtract is the equivalent of saying multiply one of them by -1. That's what this subtract means. So just be careful for that one. All right, what does A say? Multiply the first equation by -4. Hold on, no. Don't look at that. Look at this. What's going on here? What would I do? Well, I'm seeing that the x's could be eliminated if I multiply this bottom one by 2 and subtracting, or multiplying the bottom one by -2 and adding. The y's could be eliminated by multiplying the top equation by -4, making this a +4, and then I could add those two. Or I could just multiply by 4, and then I could subtract those two. And those are kind of the only only 4 options that I see. So I'm looking for one of those 4 options. So now I can go ahead and read the multiple choice. Multiply the first equation by -4. Okay, so I multiply by -4. That is one of the things I said. So if I multiply by -4, this is going to turn into a +4. And check it out. Those y's will be canceled. And then adding the equation. Okay, just making sure I'm reading correctly. A is definitely an answer. What about B? Multiply the second equation by 2. If the second equation is multiplied by 2, this is going to turn into a 6x. And check it out. They both match. Then it should say subtract. Then subtract. Good. Okay, so that one works. Multiply the first equation by 2. Okay, yeah, that one works. Wait, first equation by 2. That's going to turn this one into a 12x and a -2y. Those aren't opposites at all, so that's not going to work. So don't mark C. Oop, don't mark C. I'm just going to cross off C right here. That's not an option. Multiply the second equation by 2. Okay, multiply the second equation by 2. Okay, so that's going to be a 6x here. Let me do that in my whatever laser pointer. So 6x here, and then it should say subtract the 2 since they're the same. Multiply by 2 and then subtract. Okay, add. Okay, that's not going to work. 6x plus 6x is going to be 12x. It was really close. What about this last one? Multiply the first equation by 4. It's going to make this a 24x and a -4y. Ooh, -4y, -4y. They're the same sign, so they have to subtract. And then subtract. Okay, so that one's good. It should be A, B, and E. Number 16. Mandy solved the system equations using elimination. Okay, first of all, Mandy, we need to have a sit down. Like, this is a little bit tricky to do with elimination. The variables are not lined up. You probably had to move this x over here, and then you had to multiply the top and bottom by 3, or the bottom equation by 3. It seems like a little bit of work. Although, yeah, you don't want to do substitution because that's going to create fraction. Okay, never mind. Mandy, you get my thumbs up. Good job. Elimination is probably easier than substitution. Mandy says that the system has no solutions. Well, I don't know. I guess we need to do what she did. So if she's using elimination, let's see if we can follow in her footsteps. So I want my x's and y's to be lined up. My y's on the left, y's on the left. X on the left. This x is not on the left. You need to move over here, madame or sir, whatever gender you are. Okay, so that means I'm going to add a 3x and add a 3x, and my new equation shall be 3x plus 5y is equal to 4. And this first equation is still 9x plus 15y is equal to 6. Notice that I have my x's and my y's and my constants all lined up. So the next thing I need to do is, well, this 3 and this 9 aren't the same. I'm just going to choose to eliminate the x's because it's first. Let's multiply this bottom equation by -3. So if I do that, I'm going to do -3 right there and -3 right there. If I distribute, that's going to turn into a -9x, -15y, and -12. And 9x and -9x will cancel out as planned. What's unplanned is 15y and -15y also cancel out, which means there's nothing on the left-hand side. When you say nothing, I'm really saying 0. And on the right-hand side, I have 6 and -12, which adds up to a -6. So notice that 0 is equal to a -6. A number is equal to a different number means you cannot be true. So Mandy is saying no solutions. I agree, Mandy. I agree. Good job, Mandy. She's on it. Or maybe he's on it. I think Mandy's a girl's name. I agree. She is true. Truly correct. All right, number 17. Solve. As easy as it gets, guys. To solve this one, I'm noticing that my variables are lined up, which means I want to use elimination on this one. 11 and 4 are co-prime. They don't share any factors. So let's use the x's. If I just multiply this x by -3, check it out, check it out. -3 here and -3 here means that I'll get a -9x, and that 9x will cancel out with that one. So let me rewrite that. That's going to be a with pen though, -9x. Boink, that's that one. And -3 times 4y is a -12y. That's going to be equal to a -12. All right, let's do this. 9x minus 9x, those are gone as planned. 11y minus 12y is a -1y, or just -y. And then over here we have a 2 and a -12, which add up to a -10. negative 10. And I'm almost there. I solve for negative y. I need to solve for positive y. So get rid of the negative. A lot of students here will divide by -1, divide by -1, which is correct, but I'm going to be cooler than you, and I'm going to multiply both sides by -1, multiply both sides by -1, and I'm going to get y is equal to positive 10, which means that the second coordinate is 10 because it goes x and then y, which is what we just solved for. Okay, now that we have y, we can either plug it into u, or u. Who's easiest? I mean, that's the smallest one. So let's just plug it into that one. I'm gonna say 3x plus 4y is equal to 4. And in the spot of my y goes my 10. You get plugged in right here. And I'm gonna plug in 10 here. Okay, so what do we got? We have 4 times 10, which is 40. Zoom out just a tad here, and that's going to be added to 3x, and that's going to be equaling 4. Let's go ahead and subtract 40, and I'm going to get 3x, which is equal to negative 36. And then from here, I'm going to divide by 3, and x is equal to negative 12. Just to make sure you were following, 6 divided by 3 is 2. 3 divided by 3 is 1. Don't forget your negative. All right, so negative 12 comes up here, negative 12, and we are done. There's our answer. Moving on to number 18. Ooh, match each system of inequalities to the graph of its solution. All right, and of course the last graph doesn't fit on the page. Dang it. Okay, so this one's interesting because notice that solid line, oh, that was supposed to be a laser pointer. Solid line, god dang it, laser pointer, go gadget, laser pointer. Okay, so solid line, dashed line, dashed line, dashed line. I don't really care what the answers are. I'm looking for dash versus solid lines on this one. Notice that this one is a mixture of a dashed line and a solid line, which means it's B. Done. It's that easy. This one is solid line and solid line, which means it's C. And this one is dash line and dash line, which means it's A. That's as easy as I can make it, guys. Let's move on to another one. Number 19, fill in the blanks. Okay, Jason graphed the system of equations but did not shade the region in a way that helps him find the solution. Jason, why do we have to fix your work? Okay, so those are the two equations, and we just need to figure out, is it shading in quadrant that one, quadrant, it's not really quadrants, but that one of these 4 pieces is going to be shaded in, and we don't know which one. So really all we need, he did all the heavy lifting, by the way. He graphed the lines, he made sure they're solid versus dashed. All we need to do is do test points. So I'm noticing that this test point right here, my favorite one, the origin 0, 0 is not on either of the lines. So that means we can use it. Any point that's not on a line is a great test point. 0, 0 being my favorite because 0 times anything is 0, and it makes multiplication very, very easy. So into the first equation goes 0, 0. So this y is now a 0. This x is now a 0. Is 0 less than 0 minus 1? Let me rephrase that. Is 0 less than negative 1? No. No, it's not. 0 is not less than negative 1, which means, which equation was I testing? Was I testing that line or that line? Well, this one had no equal to sign, meaning it was a dashed line. So I was testing this dashed line right here, and the answer is it's not this one, which means we are shading on the other side down here. So let me go ahead and in my notes, I'm going to put a little highlighter tool down here of this dashed line. So it's in this section down here of that dashed line. So I have a 50-50 shot. It's between 1 and 2. Now I just need to test this solid line, which is this one right here. And I'm going to test 0, 0 because it's not on the line. So here we go. This x is now a 0. This y is now a 0. This now says negative 0 plus 2 times 0 is less than or equal to 1. Therefore, and this is why I like zeros, negative 0 is gone. 2 times 0 is gone. You're left with nothing on the left-hand side. Is 0 less than or equal to 1? Yes. Yes, it is. Therefore, it is a solution. So for this solid line, 0 is a solution, which means it should be in the shaded region. And let me do a shading in color of like blue or something. So if I go like that, like that, like that, and that, all of that stuff is shaded in. Shading is fun with technology. Okay, and where do those two shaded regions overlap? It overlaps in this region right here, which is known colloquially as region 2. The correct answer here is region 2. 2 in Roman numerals. All right, last question, number 20. Determine whether each ordered pair is a solution or not a solution to the system of inequalities. Oh, okay, well, you just plug it in and see what happens. So they have to solve for both of them, though. It's kind of annoying. Just remember that the first coordinate is always x, the second coordinate is always y, and we have to plug it in here. So let me rewrite, essentially I'm rewriting this equation down here while plugging in at the same time. The y coordinate is -2, so I'm gonna write in a -2 has to be less than or equal to a negative, because I wrote this negative, and then x is 2, so I'm gonna write in a 2 here. And unfortunately, these are exactly equal to one another, but they forgot the equal to sign here, so this unfortunately is not true. So A is immediately not a solution. You move over here. What about B? 0, 0. So again, I'm going to plug it into this. And by the way, for A, we got lucky. It has to satisfy both of these two inequalities. The fact that it didn't satisfy one of them meant we could stop there. Normally, you have to check both of them. But if it didn't satisfy one of them, then you're done. It's not a solution. If it satisfies one of these, it has to satisfy the other one as well in order for it to be a true solution. So just be warned. All right, for part B, 0, 0 being plugged into here and here. It doesn't matter which one is x and which one is y. They're both 0. So is 0 less than -0, aka 0 less than 0? Again, no, because they forgot the equal to sign. 0 is equal to 0. They forgot it, so it cannot be an answer. It has to be here. Okay, what about C? One of these has to be a solution, right? So -5, 6, let's plug those into this first equation. So y goes first, so 6 goes first. So I'm gonna say 6 is less than or equal to, or sorry, just less than negative, and then here comes my x. My x is another -5, so there's like a double negative happening here, -5. So whenever you have double negatives, they kiss and they become positive. So you say 6 is less than 5. No, it's not. 6 is not less than 5. 5 is less than 6. So yet again, we have another no solution. One of these has got to be a solution, right, guys? Let's try D. We got lucky with all three of these. It's not very much work. You just have to plug into one of them. Okay, D, let's plug you into this one again. So it goes y first. Y first is -3. So I say -3 is less than negative. There's my negative. And I'm just going to say the x again. X is -2. So it's another double negative. It's a -2, a minus a -2. Again, when negatives come together, they become positive. And it's a -3 is less than +2. And hey, yes, it is. Good job. But you just passed trial 1 of 2. You also have to pass trial 2. So I have to test the second inequality as well. So I'm going to do that down here. So it says 2x. So this is 2x. And my x in this case is the first coordinate, so -2. So I'm going to write in a -2 in here. -2. So this now says 2x plus y. Let me write the plus y. The y coordinate is the second coordinate, so -3 comes down here. -3 goes right here, and I rewrite the rest of this is greater than 2. So I have to come in here and say is greater than 2. All right, so that's -4 plus -3 is greater than 2. -7 is greater than 2. No, no, it's not. 2 is greater than -7. -7 is way far to the left of 2. Whenever you're thinking about the inequality symbol, it's asking which one is farthest to the right. If it says, 7 is greater than, then this one should be farther than right, but -7 is really far to the left, so that does not make sense. So even though it passed the first trial, unfortunately, it did not pass the second trial, so it's yet another are all of these going to be no solutions? That would be really tricky, wouldn't it be? All right, well, let's test E. And I'm feeling like we're going to run out of room, so I'm gonna do E up here. So let's do Y. Second coordinate is -6. So -6 is less than negative. I wrote this negative right here, and I'm going to do this X. And X is just a 5. So 5. And this is tricky. -6, is it less than -5? Yes, -6 is farther to left than -5, so good job. Yes, it passed trial 1, but it still has to pass trial number 2, this one right here, which is 2x plus y is greater than 2. My x-coordinate is 5, so put 5 up here. And my y-coordinate is -6, and let's go ahead and solve this a little bit more. This is going to be 10 minus 6 has to be greater than 2. 4 has to be greater than 2. Did you know that 4 is indeed greater than 2? 4 is more to the right on the number line than 2, so it passed both of them. And after you pass both of these trials, you are indeed into the Hall of Solutions. E is finally a solution. Okay, let's test F. So I'm going to do a little wavy line. Let's do F up here. So again, testing with these inequalities, it goes y, the second coordinate is -5, is less than negative, and then you plug in your x is going to be 4, so I write 4 here. Is -5 less than -4? Well, yes, -5 is more to the left than -4 on a number line, so it passed trial 1 of 2. Ooh, do we have our second answer coming in here? I don't know, we're about to find out. So now I'm going to write 2x plus y. I'm going to write 2x plus y is greater than 2. Okay, our x-coordinate is going to go first, so 4 is going to go up in here. We're going to say this is 4 and -5, and I just need to simplify you and figure out if you are a solution or not. 8 plus -5 is greater than 2. This is the same thing as saying 8 minus 5. 8 minus 5 is 3. 3 is greater than 2. Yes, 3 is bigger than 2. 3 is more to the right than 2 on a number line. And because we passed both of our trials here and here, we can say that F is also a solution. Whew. And there is the answer to number 20, and that does conclude the entire test for Unit 7. Let's go back through all of these so you can see the answers in one shot. There's page 9, didn't use page 8, page 7, and we've got them all. It's beautiful. Wow, look at all that work. So pretty. Thanks for watching, guys. I'll see you later.